Hi everyone, welcome to the Art Directable Procedural Pipelines talk with PDG. Now, it's quite important to be able to mix manual and procedural workflows, and this is a problem that hasn't been well solved so far. Aspects of this talk have been touched upon in some other talks, but the content is a little bit scattered, and so this being the important topic that it is, I thought I'd basically kind of bring everything together into a single talk where that may become a little more clear. So the basic problem we're trying to solve is this one, right? Here I've got a procedural building and I've got a little flower pot placed in front of it. Basically, if I go and update the parameters of this procedural building, let's say making it a bit wider, then what could happen is these two things simply don't know anything about each other, and so now the building gets wider, and so now overlaps with the flower pot placement, which is manual, right? And so this is a pretty well-known problem and not well solved. And in my travels, basically seen it approached a couple of ways. The most naive way is simply to say, hey, once we put the flower pot down, that thing is frozen. Just don't ever touch it again. Don't do that procedural adjustment anymore. But of course, then you lose the benefit of proceduralism if you can't go and make any more adjustments. Or if you are forced into making an adjustment, then you end up losing your manual edits, which is equally bad, I guess. A slightly better approach is to use layers where the procedural stuff goes to the base layer and the manual edits are stored as deltas on top of that base layer. This works for some stuff, such as terrains, but it's limited in the sense that when you create layer systems, generally you have to make some assumptions on what it is that you're layering, whether that is, say, animation, or in this case, position of objects. So that imposes some restrictions. So it's not completely general. Now, finally, in today's talk, we'll look at PDG mappers, which provides a much more general framework to solve this problem, and as we'll see, is a superset of the layers approach. Now, before we go and look at a solution, let's take a look at the requirements that any particular solution must have to this problem. So firstly, manual edits must be recorded. If there's no record that an edit has taken place, then we certainly couldn't go and reapply it, right? And secondly, that record, once recorded, must be protected from upstream procedural changes. We can't just get it to have it blown away because we made some modifications upstream, right? If it does get destroyed like that, there really was no point of it being recorded in the first place. And thirdly, and somewhat subtly, the manual edit must be faithfully reapplied and faithfully being underlined here. That's because you'll see that we can actually, depending on the way we record the information, we can certainly do it in a way that's bad, that prevents us from being able to faithfully reapply the manual edit as the user intended. And the key to this is that the edit must be stored in a way that is independent of the shape of the upstream procedural data. So maybe some examples will make these points clear. So if we look at our first naive case here, where we had the procedural building and this planter placed here, the big problem is that, of course, that there's no record of that manual edit at all. This planter doesn't know anything about the fact that there's this procedural building. And so when we make a change to the procedural building, it will simply overlap it, right? So here, the big problem is that there's no record of this edit at all. Now, let's take a look at a case of storing the edit data in a bad way. So here's an example where we could store the edit data in a way that is dependent on the shape of the procedural data. So for example, we could say, well, this planter is to be about 15 units away from point 8 of this building, okay? So if we encode it this way, in some cases this will work when when the topology of the building, of the underlying geometry doesn't change. But if we tessellate the building so that the topology changes and now there are more points, well, point 8 could all of a sudden end up being up here. And because we've encoded the edit in a way that is dependent on the shape of the procedural data, well, then now our manual edit is, when it's reapplied, it's now wrong because now point 8 is here and it's going to apply it, put this planter about 15 units away from point 8, which leaves it floating in space, right? So finally, let's take a look at an example of a good storage of the edit such that it's independent of the shape of the procedural data. So in this case, our description of where the planter should go is that this planter is to be on the ground and it's 15 units away from the southeast corner of the building. Now, when we encode the data this way, when we make a procedural edit and the building gets bigger, first we can then cast array, which is this green line here, to find out where is the new location of the southeast corner of the building. And once we know that, we can measure 15 units from that and put our planter there. And therefore, this is a faithful reapplication of the manual edit that the user intended. Okay, so now that we have taken a look at the requirements, let's take a look at the actual solution. It turns out that in PDG we have this construct called mappers that actually is a really good fit to solve this problem because it satisfies all three of these criteria. It allows the manual edits to be explicitly recorded as a work item. It protects those work items from upstream procedural changes. And then it allows you to reapply these manual edits to the updated procedural data upstream once you do make it. Now, users are still responsible for having a good representation of the manual edit data. The mapper construct is completely general and doesn't force that on you, so you can still go and represent it in a bad way. But suppose you do have a good representation of the data such that it's independent of the upstream procedural content, then you'll be in good shape. Okay, so which might beg the question, what are mappers anyway? Well, mappers are basically these nodes that are able to tie together two procedural chunks of the PDG graph. Now, you might say, what is a procedural chunk? What's the definition of that? Well, a procedural chunk is just some combination of processors and partitioners. Now, typically in a procedural chunk, downstream work items are sort of synthesized from upstream ones, right? So when you go and make an upstream change, these downstream work items are not protected, and so they're zapped, they're destroyed, right? But what mappers do essentially is that it acts as a shield to the work items below it, so that work items below the mapper are not affected by procedural changes to procedural data upstream of it. They're going to be shielded and they're going to be kept around. And as you'll see, these mappers allow general rules to associate work items below the mapper to those above. So maybe an example will make this clear. So next, let's take a look at that. Okay, so I've got my session of Houdini open here, and I've got a very simple setup that we're going to use to illustrate this. So basically, I've got 1, 2, 3 processors, followed by a map by index, followed by another processor. The first one just generates 3 work items, followed by, for each one of those, I'll generate 2 work items. So 3 times 2 is 6. And this guy is just basically doing re-indexing, right? So we can see that basically we're re-indexing things so that all these work items will either have an index of 0 or an index of 1. Okay, that's all we're doing. And below this mapper, we'll have 2 work items here, and they're going to map by index. So the first work item would have index 0 and would relate to all the ones with index 0 above. And the second one would have index 1 and relate to all the ones upstream also with an index of 1, right? So now the first thing you'll notice here is that as I dirty and mess with the upstream work items here, these guys are shielded, right, by the mapper. They're not blown away, even as I've blown everything upstream away, right? So when I recook, it'll go and faithfully re-establish those connections again. Now, what if I go and increase this count from 2 to 3, let's say, right? And let's dirty this node one more time. Once again, you notice these guys are kept around, but even more interestingly, when I recook this, you'll notice that it now reestablished the connection again, but now it's taken the new information into account, right? There are more work items now with index of 0, and it reestablished the connection to all of those. And likewise, the ones with an index of 1. So for example, if this were a manual edit, for example, to, let's say color certain buildings red in a certain area, well, what I just did could represent the fact that, hey, we started with 3 buildings, but now there are 5. This was able to take the new buildings into account and also color those things red. And this might be a similar operation to color certain buildings blue, for example. And again, it took that new information into account and faithfully did that, right? Now, I just want to make a quick little point here to see that mappers are a superset of the layering system. You can see that just by this little setup here. Layering system essentially can be simulated by alternating mappers with single nodes in it. So this would be the base layer. This would be layer 1 that's applied on top of the base layer, and then similarly layer 2 applied on top of layer 1, right? But we don't have to stop here with the PDG setup. We could in fact have something more like this, where instead of just doing one thing in layer 1, I can do multiple things where it actually fans out and potentially fan back in. And likewise in layer 2, I can do all kinds of stuff, fanning out and fanning back in, right? So it's not just a single operation that would be the case. In a regular layer system, you can actually do a whole bunch of procedural stuff in each quote-unquote layer in the PDG mapper system. Okay, so now that we understand what mappers are, the next question is, well, how are you supposed to work with these things? The short answer is by injecting, quote-unquote, injecting these work items into the right spot. We have these APIs both in Python and through Happy, which is the Houdini Engine C API, to insert work items anywhere in the graph. Okay, so the idea is that every time the user makes a manual edit, we basically invoke these APIs to insert the work item to the processor below the mapper into the right spot. Okay, so next, let's take a look at an actual example of this in action. Okay, so this is what we're trying to achieve here in this realistic scenario. So we've got these rocks, we've got these lightning, and we'd like the user to be able to direct where the lightning is supposed to strike and still allow upstream procedural changes to these rocks while still persisting the manual edits that was made to these lightning strikes. So let's take a look at how we're doing that. All right, so we have a PDG graph here. Okay, so now we're going to go in and do some manual edits on where the lightning is supposed to strike. So for that rock, we specified these 2 locations, right? So now notice there's a work item that has been injected into the right spot. Now we're going to cook the rest of the graph downstream of that lightning stroke. Okay, and as it completes, we click around on these lightning strikes that are a result of our manual edit, you can see it's striking in one of those 2 spots. Now we're going to go zoom out and notice that we're going to make an edit that's upstream of what we just did, right? So we're changing now the shape of the rock by changing the random seed and all kinds of other parameters, but notice it was actually upstream of the manual edit. I'm going to recook some stuff. And all the rock cooking is almost done, and there we go. Okay, you just see all the rocks just change shape right there. Okay. Now, as we go to the spot where we had the manual edit, notice that the manual edit was not blown away. This was kept below the mapper. And as we dirty and recook this bit, now we've reapplied the manual edit now with the new rock shape, right? And you can see it's still striking in those 2 spots. But just to be clear, we're going to have the old rock shape and new rock shape side by side. Here we go. And you can see the lightning strike. Even though the rock shape is different, the lightning is still striking in the same spot.